After 1 billion years, the Milky Way and the Andromeda galaxy, two majestic spiral galaxies, will embark on a cosmic collision of epic proportions. The celestial dance, fueled by an inexorable pull of gravity, will reshape the night sky as we know it. As the two galaxies draw nearer over the course of hundreds of millions of years, their vast clouds of stars, gas and dust will interact in a cosmic ballet, leading to the eventual merger of the galactic cores. The collision will trigger intense star formation, causing the birth of new stellar entities amid the chaos. The merger will give rise to a new, larger elliptical galaxy with the remnants of the once distinct Milky Way and Andromeda, contributing to the formation of a harmonious galactic amalgamation. This cosmic union, spanning billions of years, will leave an indelible mark on the evolving tapestry of the universe, showcasing the dynamic and transformative nature of galactic evolution on a grand scale. After approximately 5 billion years, the Sun, like all stars, inexorably progresses throughout the final stages of its life cycle, marking the culmination of its stellar journey. As the Sun depletes its primary fuel, hydrogen, in its core, it will undergo a profound transformation. The outer layers will expand, engulfing the inner planet, including Earth, in a fire embrace as it transforms into a red giant. The once serene and life-sustaining star will metamorphose into a celestial behemoth. Its outer layers expelled into space to form a luminous shell known as planetary nebula. Subsequently, the remnants of the Sun's core will contract and evolve into a white dwarf, a dense and dim stellar remnant. Over trillions of years, this white dwarf will gradually cool and fade, becoming a dark inert object known as a black dwarf. After trillions of years, the universe will undergo a transformative journey into a state known as the cosmic dark era. As stars exhaust their nuclear fuel and cease to shine one by one, the night sky will lose its radiant beacon. The process of star formation, which have fueled the brilliance of galaxies and countless eons, will come to a gradual halt. The universe, once aglow with incandescence of stellar nurseries, will be left with aging, dim stars and remnants like white dwarfs, neutron stars and black holes. During the cosmic dark era, white dwarfs, the remnants of stars like our Sun, will persist as inner dense objects. Though they will continue to cool over unimaginable time scales, they themselves will not contribute new light to the dark cosmos. Instead, they will gradually fade into obscurity, becoming cold dark spheres, testimonies to the once vibrant stars that graced the celestial expanse. Concurrently, black dwarfs, which are hypothetical end states of white dwarfs, after they have radiated away all the residual heat, will be a manifestation of the ultimate stellar fate. However, the process of a white dwarf to become a black dwarf is so incredibly slow, on the order of time scales vastly exceeding the current age of the universe, that the existence of true black dwarfs is largely theoretical at this point.
The universe is getting bigger every day. And what we understand now is that the amount it's getting bigger is getting bigger every day. The expansion of the universe is accelerating.
So what will be the future of the universe? Well, if the dark energy remains dominant and repulsive, the universe will expand forever. Faster and faster and faster with time. A runaway universe.
From the outside, you can't tell what is inside a black hole. You can throw television sets, diamond rings, or even your worst enemies into a black hole, and all the black hole will remember is the total mass and the angular momentum and electric charge. Quantum mechanics implies that the whole of space is filled with pairs of virtual particles and antiparticles that are constantly materializing in pairs, and then coming together again and annihilating each other. One member of a pair of virtual particles may fall into the hole, leaving the other member without a partner with which to annihilate. The forsaken particle or antiparticle may fall into the black hole after its partner, but it may also escape to infinity, where it appears to be radiation emitted by the black hole.
After an unimaginable length of time, even the black holes will have evaporated, and the universe will be nothing but a sea of photons gradually tending towards the same temperature as the expansion of the universe cools them towards absolute zero. Once the very last remnants of the very last stars have finally decayed away to nothing, and everything reaches the same temperature, the story of the universe finally comes to an end. For the first time in its life, the universe will be permanent and unchanging. Entropy finally stops increasing because the cosmos cannot get any more disordered. Nothing happens, and it keeps not happening forever.